Good afternoon, students. It's Mrs. Cinti here, and I am here to teach you a little bit about section 2.2, simplifying and evaluating algebraic expressions. Sounds complicated, but I think you're going to enjoy it. So to evaluate an algebraic expression, what you will do is you will substitute the value in for the variable. A given value in for the variable. So let's go ahead and change colors. Let's say that I have something like A plus B divided by C, and it tells me A is equal to 5, B is equal to 10, and C is equal to -3. So what we'll do is we will substitute. So A is 5, so 5 plus B, we plug the B in for 10, and then C is equal to -3. So remember that I like this to be set up in your notes above each other, like right below it. So the next step, the next step, the next step. So unfortunately, I don't have enough space, so I'm going to go ahead and draw an arrow indicating that this should actually go underneath. So 5 plus 10 is 15 divided by -3, I rewrite, and then 15 divided by -3 gives me a -5, and then I circle my answer. Okay, that's the way that you want to do it. You want to avoid having equal signs to the next one. We just want to do it sequentially below each other. Okay. One thing that's, and the instructions here would be to evaluate, which I forgot to write there, sorry. So evaluate this, A plus B plus C, if A is equal to 5, B is equal to 10, and C is equal to -3. Okay, let's discuss another vocab kind of term here, and it is a term. Okay, so a mathematical term, these are examples. 3x is a mathematical term. 5y divided by 3 is another term. 214zk is another term. So this right here is a term. This is a term. This is a term. And this is a term. And so what they are, terms are separated by addition or subtraction signs. Okay. What we do is we simplify algebraic expressions. So we're still in the expression phase. Oops. Expressions. By combining like terms. Okay, and we have to define what like terms are here. But like terms is the key. Okay, like terms, and I'm going to try to squeeze it in here just to keep it all on one page. They have the same variables, and those variables have the same exponents. Okay, so here, this is not a like term to this, because a like term to this would have an x in it. If this were indeed an x, then these two would be like terms, because this is x to the first, and if this were an x to the first, then you could combine these terms, okay? If you could actually combine them, which you probably could not do. 2 doesn't have a variable with it, but it could be, if it was a +3, these two would be like terms and you can combine them, okay? If we had plus 2zk, then you could combine these two terms, okay? So -14zk plus 2zk would give you a negative 12zk. But we're going to do a whole bunch of fun examples this way. So let's go ahead and clear this. Let's go ahead and do some examples. So 2ab plus 2a plus b squared plus 5ab. Okay, this has how many terms? 1, 2, 3, 4 terms. So it is a 4-term expression. Okay, and then we are looking for the things that can be combined. So as you are seeing, this one has an AB, an exponent. This one has an A, but it doesn't have an A and a B, so this cannot combine with this one. These are not like terms, they're unlike terms. This is b squared, which isn't similar to either of these. And then this is 5ab. Ooh, ab to the first, a to the first, b to the first, same as this. So you can combine these two. These two are known as like terms. Okay, like terms. So what we would do is we could rearrange them using the commutative property 2ab plus 5ab. Remember that we keep these together. The addition sign in front of it is kept together. If this was a subtraction sign, we would keep that together. Okay, so it's a positive 2ab plus a positive 2a plus a positive, positive. It's all positive, so we bring the positive 2a here, the b squared here, and then we can combine these. So 2 apples and bananas plus 5 apples and bananas gives us 7ab plus 2a plus b squared. And that's how we would simplify the problem. Okay. Another example might look like this. 2x squared plus 5x squared plus 1x squared. Okay, these are all like terms. They all have the same variable with the same exponent on them. So we could say 2 dogs plus 5 dogs plus 1 dog. 2 plus 5 is 7 plus 1 is 8. 8x squared. Okay, that would be the simplified version of that because they are all like terms. Okay, let's go ahead and let's look at a little bit more. So these are more straightforward examples. Let's look at some more. Remember, or maybe you don't remember, but vocabulary we're going to throw in here. This right here is known as a coefficient. Okay, and this is known, as we've said already today, as a variable. Okay, so coefficients and variables. A question might be, what is the coefficient? Of, let's say, b. And the answer would be 1. Okay, 1 is in front of that. So just to remind you of that. What is the coefficient of 2, or 6 to the 10th power? And the answer is none. There are no coefficients to these. These kind of are the values that they're called constants. Okay, so let's go ahead and try, now that we have a little bit more vocabulary with us, let's go ahead and try a couple of examples. So 3m squared n plus the absolute value of negative 8 plus 2m squared n. Okay, so what are we going to do first? We're going to look for, let's go ahead and take care of this absolute value sign. So we'll rewrite it, 3m squared n plus the absolute value means how far away is negative 8 from 0. It is 8 places away, plus 2m squared n. We identify like terms to further simplify it. This term and this term are similar because it's n to the first power, m to the second power. Here again is the same thing. So we can combine these two. You don't have to rewrite it using the commutative property if you don't want. You can just identify that those are there. Plus 8. And that's as simple as you can do it. You cannot combine those terms. Another example to put down in your notes, 6w subtract w plus 3. How do you simplify this? Look for like terms. 3 is a constant, so not a, it doesn't have a variable. W, this is 1w to the first, imaginarily, negative 1w to the first, and here's 6w. So 6 minus 1 is 5w plus 3. Okay, and we circle our answer again. And then let's try one more difficult one, and then I'll set you free. Xy squared plus 5 plus 3xy squared minus 2xy squared plus the absolute value of negative 7. So our job is to identify like terms. Here's xy squared, nothing. Xy squared, okay, these are similar. This is similar. Oh, and here's a negative 2xy squared. This is going to be a constant when we turn it into something. So let's go ahead and we can add these three together now and subtract. Here's 1xy squared plus 3xy squared, which gives us 4xy squared, minus 2xy squared would give us 2xy squared, plus 5, so we bring this down, and then plus the absolute value of negative 7, which is really saying how far away is negative 7 from 0. So we rewrite again, 2xy squared plus 5 plus 7. And so we can combine these two like terms, 2xy squared plus 12. And then we circle our answer confidently. Okay? Very good. Okay, have fun doing your practice. And remember, I'm here for any help that you may need.